Hi, my name is Scarlett and I'm going to explain the problem 3.18 from Chapter 3, Experiments with a Single Factor, the Analysis of Variance Problems. The problem says, a manufacturer of television sets is interested in the effect of tube conductivity of 4 different types of coating for color picture tubes. A completely randomized experiment is conducted and the following conductivity data are obtained. Here is a table with the 4 types of coating and the numbers of all the conductivity. The first question is there a difference in conductivity due to coating type? To get the answer of this question, we have to do the process of ANOVA, and I'm going to explain how this is made. You have to obtain first the sum of each row 143 plus 141 plus 150 plus 146, and it gives us 580. You have to do this with every row, and then you have to obtain the overall sum. This means to sum each of the other sums that you obtain. Then you have to obtain the amount of numbers of the conductivity. In this case is 16. So we have to obtain number that in this case is the sum of squares of the conductivity. And this is obtained by checking the sum of squares of the sum we obtain in each row and divided by the number of columns. In this case is 4. You have to subtract the square of the overall sum divided by the amount of numbers that in this case is 16. That gives us 844.68. Then you have to obtain the total of the sum of squares, and this is obtained with this formula. That is the sum of squares of all the numbers of the conductivity minus the square of the overall sum divided by the amount of numbers, that is 16. And this gives us 1080.9375. Then you have to obtain the error. This is simply obtained by subtracting the total sum of squares minus the conductivity sum of squares. Then you have to get the degrees of freedom. To obtain the degrees of freedom of conductivity, you have to see how much rows or types you have in the table. In this case is 4, and you have to subtract 1. So it's 4 minus 1, 3. To obtain the total, you have to check the amount of all the numbers and subtract 1. In this case is 16 minus 15 is 12. So when you subtract the total minus the conductivity, it gives us 12. To obtain the MS error, you have to divide the sum of squares divided by the degrees of freedom. And it's the same in the error. The sum of squares divided by the degrees of freedom. And finally, you have to take the F-test statistics, and this is obtained by dividing the MS conductivity by the MS error, and this gives us 14.301. Then to obtain the final hypothesis, you need to go to the F table and check what number you are going to have. So the problem tells us that we have to use alpha with 0.05. So you have to go to the table and check the 0.05, then the degrees of freedom of the conductivity and the degrees of freedom of the error. And this gives us 3.49. Because of the number that we obtain in the table is smaller than the F statistic, of the F test statistics, we have to accept the null hypothesis. And this tells us that there is enough evidence to say that there is a difference in conductivity due to a coating type. The next question is to estimate the overall mean and the treatment effects. This is obtained by taking first of all, the averages of every row. So you have to take the average of row 1, then row 2, row 3, row 4. And these are the answers. Then you have to obtain the overall average. That is the average of all the average that we take. So to obtain that treatment, we have to compare the overall average with the average we obtain in each row. So we have to subtract the average, the original average, minus the overall average, and that is with each row. You have to subtract the average minus the overall, and we obtain in that way the treatments. The next question is compute a 95% interval estimate of the mean of coding type 4. Then compute a 99% interval estimated of the mean difference between coding types 1 and 4. First, we are going to obtain the 95% interval. So this means that we have an alpha of 0.05. So the formula tells us. The next question is compute a 95% interval estimate of the mean of coding type 4. Compute a 99% interval estimate of the mean difference between coding types 1 and 4. First, we're going to obtain the 95% interval. This means that we have an alpha of 0.05. The equations obtained this tell us that in the t-table we have to divide alpha divided by 2, comma, n minus a. That in this case is 16 minus 4 because we have 4 types of coding. So we go to the table and it's 0.025, comma 12, and this gives us 2.79. To obtain the inferior number, we follow the formula, that is the average that we have to obtain by the coding type 4, that in this case is 129.25, minus the value obtained in the t-table, that in this case is 2.179, times the square root of the MS error divided by 4 because we have the 4 columns. And this gives us 124. And the superior number is obtained the same, but instead of subtracting is adding. And in the 99% interval estimate, but in the difference between coding type 1 and 4 is a little different. This means that we have an alpha of 0.01. So in the t-table we have to divide 0.01 by 2, comma 12. So we go to the table and it's 0.005, comma 12, and this gives us 3.055. So to obtain the inferior number, we follow the formula, that is average of coding type 1 minus the average of coding type 4, minus the t-value 3.055 times the square root of 2 times the ms error divided by 4. And this gives us 6.165. And in the superior is the same, but instead of subtracting is adding. The next question is test all pairs of means using the Fisher LSD method with alpha 0.05. The formula to obtain the value of LSD is this one. So we know that the t-value with the alpha 0.05 is 2.179, and the ms error we also know that is 19.6875. So to obtain the value of LSD is simply multiplying the t-value times the square root of 2 times the ms error divided by 4. And this gives us 6.8365. This value is going to be used to compare by the subtraction of each of the following types. You have to subtract every average with each with the other ones, each one of them. So in this case is 1 minus 4, 1 minus 3, 1 minus 2, 2 minus 4, 2 minus 3, and 3 minus 4. And we obtain that the only differences is in 1 and 2 and 3 and 4 because are smaller than the value we obtain in the LSD. This means that the means of coding type 2 and type 1 are statistically the same, and the means of coding type 3 and 4 are statistically the same also. The next question is use the graphical method discussed in section 3.5.3 to compare the means. Which coding produces the highest conductivity? To obtain this, we use this formula. So we know that the ms error is 19.6875, and this gives us the square root of the ms error divided by 4 gives us 2.2185. This number is going to use to obtain to compare by the results we obtained before in the question. So the only difference is in average 1 and average 2 because the value is smaller than the one we obtained. So this means that the coding type 1 and 2 produce the highest conductivity. And here is a small graph to explain how it is obtained. And the last question is, assuming that coding type 4 is currently in use, what are your recommendations to the manufacturer? We wish to minimize conductivity. And the answer is, since codings 3 and 4 do not differ, and as they both produce the lowest mean values of conductivity, use either coding 3 or 4. It's the same. But as type 4 is currently being used, there is probably no need to change because it is a good option to continue using them.